Hello chemists! Today we are talking about polyatomic ions. Our big idea today is that atoms in covalent compounds share electrons, and we'll talk a little bit more about how that fits in after we've established some vocabulary. So let's start by talking about types of ions. The one that you are most familiar with is what we call a monatomic ion, which is one element that carries a charge. Today we're going to learn about polyatomic ions, which is where there are two or more elements bonded together, and together they share a charge. So here we have hydroxide, or an oxygen and a hydrogen bonded together that together have a -1 charge. If we think about the prefixes here, we know that mono means one and poly means many. So monatomic, one element, polyatomic, many elements. Probably not too many. And now let's talk about types of bonds. We've previously talked about ionic bonds, which is when a nonmetal steals an electron from a metal. So this is like oxygen taking 2 electrons from magnesium. We see that magnesium has an empty valence shell and oxygen has a full valence shell. Because these two elements have opposite charges, they are essentially attracted to each other. Their bond is because of that attraction between the charges. Magnesium is sort of following oxygen around, keeping track of its electrons that oxygen has taken away, and feeling the pull of that negative charge. A covalent bond is a bond where multiple nonmetals share electrons. We know that nonmetals usually have mostly full valence shells, so they're not really going to give them up, but they'll share them. Here we have hydrogen. It has 1 valence electron, and oxygen has 6. And what we see happen is that there is a sharing of electrons. You can see the overlapping valence shells with 1 electron from oxygen and 1 electron from hydrogen. And then a gained electron, right in the green there, that it stole presumably from some metal that gives it the -1 charge. So the key here, the covalent bonding, is those shared electrons and overlapping valence shells between hydrogen and oxygen. And that is what is happening inside of our polyatomic ions. So in a polyatomic ion, a group of atoms share their valence electrons and they're sharing the charge. It's a covalent bond. Let's look at another example. Nitrate is a polyatomic ion that has 1 nitrogen and 3 oxygen atoms. Together they share a -1 charge. Here is the structure of nitrate. We know that each of these atoms would like to have 8 valence electrons. For the 2 oxygens, the one in the middle and the one on the right-hand side, we can clearly see 8 electrons in those rings. Some are shared from nitrogen, those are the blue electrons, and 1 has been stolen, that's our -1 charge. The nitrogen and the left-hand oxygen look a little trickier, but they're actually sharing 4 electrons. So this oxygen has 4 of its own electrons, and then those 4 shared for a total of 8. You don't need to worry too much about this. I just think sometimes it's helpful to think about how this sharing is happening. Here's a list of common polyatomic ions and the ones that you'll see in this class. I'm going to say the names out loud to help you with the pronunciation, but I recommend that you come back to this list frequently. Nitrate is NO3 with a -1 charge. Hydroxide is OH with a -1 charge. Cyanide is CN with a -1 charge. Sulfate is SO4 with a -2 charge. Chromate is CrO4 with a -2 charge. Carbonate is CO3 with a -2 charge. Phosphate is PO4 with a -3 charge. And ammonium is NH4 with a +1 charge. This will be our only cation polyatomic ion. Lastly, let's talk about how to name polyatomic ions. Polyatomic ions have specific endings, which you saw in the previous slide, and so we're not going to change the ends of them like we would a monatomic ion. So here we have sodium nitrate. Nitrate keeps that ATE ending. In the case of ammonium chloride, where the polyatomic ion is the cation and comes first, and chlorine is the monatomic ion, we'll still change the ending of chloride because it's not the polyatomic ion. The other interesting piece is in the formulas. When we have more than one of a polyatomic ion, we'll wrap the polyatomic ion in parentheses and then put a subscript on the outside to show how many polyatomic ions there are. So in our first example, we have magnesium nitrate. We have one magnesium. Nitrate is NO3, wrap it in parentheses, and put the 2 on the outside. Our second example is ammonium oxide. We have 2 NH4s, 2 ammoniums, so we'll wrap that NH4 in parentheses, put a 2 on the outside, and then put our single oxygen at the end. That's it for today. If you have questions, please leave them in the comments below.